Okay, fun fact of the day. I would have done this earlier, but clumsy Mr. P cracked his computer screen, so not so fun, but quite entertaining. Alright, so we are at 2.3 volume of cylinders, cones, and spheres. It's a little strange for them to put it in here, considering we did this in the 7th grade unit already, but I think it's in here because they want you to see the equations and the way it's used. And combined with each other. So before you were just finding them, now you're using the equations in with generalizations, basically. Alright, so volumes of cylinders, cones, and spheres. I lost track of page numbers already. Sorry about that. But you should know what the page numbers are. Fingers crossed. Alright, so volumes of cylinders, cones, and spheres. What equations represent the relationship among volumes of cylinders, cones, and spheres? So these are all in your textbook, and this is just a kind of a reminder for you. These are all already given to you, so I figured making you look it up was kind of pointless. So they're all here, and feel free to copy this down as a reminder. Yes, just give it a quick sketch and a quick draw. Sphere, cone, and cylinder, and these are the equations. Now, all of these cones and cylinders and spheres, they all have something in common. They all have the same radius. Okay, so this only works if the radiuses are all the same. Okay, so this radius is the same as this radius, the same as this radius, and they're all the same height. As you can see, they're all the same height. Okay, so the cylinder is pi r squared. This is the base. This is the base. Now the base can also be described as area of a circle So that's the area of this bottom circle right down here. That's the area of just this bottom layer, and this says how many layers do you stack on top. Okay, times the height. Okay, in this case, the height is unique because of the sphere, and we'll get to that in a second. If you divide this into 3 parts, you can get the volume of a cone. This is all volumes, so the volume of a cone. So what you'll notice is we use the exact same equation again, volume of a cylinder, and we use it to find the equation of a cone. So I have to use the same thing. There's a cylinder, but the only thing that's different is I divide it by 3. Okay, it's 1/3 the volume, so 3 of these will fit in there. Okay, if we continue on, what you'll notice is this divided by 3 is still there. This original equation of pi r squared is still there. But the only thing is at the end we double it. Okay, doubling it, so 2 cones equal 1 sphere. There are many different ways to write this, and that's actually question B. Different ways to write these equations. Okay. The unique thing about here is the height of this sphere. Okay, the height of this sphere can also be written as 2r because it's a circle. The radius here is the same as the radius here, so that's a radius as well. To get to the bottom, that's another radius, so that's radius plus radius, which means that the height of this is 2 radius. Okay, now if I did that and multiplied everything across, we can come up with a lot of different equations, and we'll come up with that in question B, C, and D. Okay, so you should have these equations, maybe a quick sketch. The area of the base of the circle is covered in this section right here. That's important to know. This is the base or the area of a circle. And he decided to explore, this is on page 32. And he decided to explore the relationship among volumes of 3 candle designs. He used plastic containers in the shape of a cylinder, cone, and sphere. The containers have the same height and the inside radius, which means that the inside diameter of the sphere is equal to the height. So you can see the diameter is equal to the height. That means the diameter is h, and the diameter is also 2r. So 2r is the height. And he tried to find relationships among the 3 containers. Number 1, write the relationships among the 3 containers in words, then as algebraic equations. Okay, so pretty easy. If you want to write this out on your own, you may. You don't have to listen to me and do it, but here's my explanation. So number 1, and let me shrink this down, it's a little too big. the cone is one third the volume of a cylinder. There you go. And you can say a sphere is double the volume of a cone. Okay. You can also say, or a sphere is 2/3 the volume of a cylinder. Okay. Now 2/3, I say that because as we did before, we divided it by 3 to get the cone, and then we doubled it. So divide by 3, then times 2. Okay. I'm not going to write the algebraic equations because those are just formulas, and there they are. They're already there. We've already done that. Use the relationship in part 1 to write expressions for finding the volume of a cone with height h and radius r. Okay, so I'm going to write this equation. We've probably already done it, but here it is again. Okay, find the relation in part 1 of a cone with the height h and radius r. So a cone is going to be the base pi r squared times height divided by 3. You could also write or pi r squared times h times 1/3. These two are the same. Okay. A sphere with the radius r. Okay, so this is telling us a sphere with the radius r. So from here to here, that's r. That means from here to the top, that's also r. And from the middle to the bottom, that's also r. So they're not giving you any heights. So we can say that this one is going to be pi r squared, that's my base, divided by 3. Okay, that makes my cone. And I need to multiply by the height. But the height is unknown. Well, not really unknown, we just don't have the height here. But the height is equal to 2 radiuses, or 2 radii. Height plus, radius plus radius equals our height. So this, that's my height. And then I got to multiply it by 2, because that's 2 cones. So if I put this all together, I can leave it like that. That's a true statement. Or I can say pi r squared times 4. 2 times 2 is 4, right? And then times another r. Well, that's confusing. I don't want to have those r's separated from each other. So I'm just going to combine them together. All this divided by 3. I'm going to combine my r's together now. So I can say that this is going to be pi r cubed times 4 divided by 3. There's my sphere of my volume of a sphere. All right. The price of each candle is based on the cost of wax. If the cylinder candle costs $12, what should be the price of the other 2 candles? Here's my cylinder, which is $12. Okay. To find the cone is 1/3. So cone is equal to cylinder divided by 3. In this case, that means $12 divided by 3. The cone should be 12 divided by 3, which is $4. Okay, I can do the same thing for the sphere. The sphere is the cylinder divided by 3 and then times 2. I can say 12 divided by 3 times 2, and I get 12 divided by 3 is 4, times 2 is going to be $8. So the sphere should be $8 and the cone should be 4. Okay, I'm going to stop there. I'll let you guys work on question D on your own. It's not too difficult. Okay, you have one homework assignment and you can start now. Okay, your one homework assignment is going to be your partner quiz. Okay, it'll be due, well, if a good amount of you don't finish before the end of the class, will be due next class. But you should be able to finish it by the end of this class. Okay, so here are your restrictions or your rules or whatever you want to call them. Okay. Partner quiz. You get to one, work with a partner at your table only. Okay. Everyone gets their own test, their own quiz. 2. Everyone gets their own quiz, but you can work together. You can put all the same answers if you'd like to, but everyone's gonna get their individual grade. You just can work with each other. Okay, and then 3 will grade this in class together next class. Graded together next class. If you finish early enough today, you can grade it today. Ms. Porter should have the answer key in case you guys want to grade in class. Alrighty. Be good, and I'll see you guys next week.